Hello. So this is Algebra 2, Chapter 3.5, Algebra 2, Chapter 3.5, and solving non-linear functions. So up till now, we've been doing linear equations like the x to the power of 1. So in non-linear means like one, we can have the equation as y is equal to 2x plus 5, and the other we can have as y is equal to x squared plus 2x minus 5. So this is not linear and this is linear. Okay. So when we do problems, it will become more clear. If they intersect, they can have one no solution, means like this, means they will never meet. They can have one solution like this, they meet at one place, and they can have two solutions like this. Okay. So let's do some questions and then it will become more clear. So this is question 21 from 3.5, and we have to solve it by substitution, using substitution method. So this is equation 1 and this is equation 2. So we have to solve it by substitution. So we'll substitute y from equation 1 in equation 2. So now we'll simplify this. So in this, simplifying this would be like will give us negative 2x square plus 1 like this. Okay, then we'll add negative 1 to each side. So this will give negative 8 is equal to negative 2x square. And then we'll divide by negative 2 to each side, which will give x square is equal to 4. And then when we square root, we get x is equal to plus and minus 2. So now to solve for y, we have to substitute x is equal to plus 2 and minus 2 both. So we see that we got x is equal to plus 2 and minus 2. So we substituted x is equal to plus 2 and we got y is equal to 3. So this is one of our solution. And here we substituted x is equal to negative 2 and we got 3. So this is another solution. Okay, let's do one more problem. So these are the two equations given here and we have to solve it using substitution. So the first equation here, this is equation 1 and this is equation 2. So from equation 1, we see that y is equal to 4x square minus 16x plus 22. So we'll substitute this for y in equation 2 here. Okay. Instead of this y, we will write 4x square minus 16x plus 22. Now we'll simplify it. So on simplifying, we get this. Now we see that all are divisible, all coefficients are divisible by 8. So let's divide. So we can factor we can factor 8 out and then we can divide by 8. Now we can factorize it like factor 6 in such a way that when we add, we get it 5 and when we multiply, we get 6. So this is, we factorized and we got this. Now, because of the zero product property, either of the factors should be 0 to get the answer 0. So x minus 3 is equal to 0 and x minus 2 is equal to 0. So from this and this, we got x minus 3 is equal to 0 and x minus 2 is equal to 0. We got two values, x is equal to 2 and 3. Now we will substitute the values and in this equation and get the value of y. So when we put x is equal to 3, we get y is equal to 10. So if we put x is equal to 3, we get y 10. And if we put x is equal to 2 here, we get y 6. So our solutions are 3, 10, and 2, 6. So this is how we solve these equations using substitution method. Now let's try how we'll do elimination. So this is the equation given to us, question 32. These are the two equations, 1 and 2, and we have to solve by elimination. So we can add both of them. If we add y minus y, okay, we are adding 1 and 2. So we see that when we add 1 and 2, y minus y becomes 0, and x square, 4x plus 4x is 8x plus 14. Now we cannot find the factors of 14 which can add or subtract to give 8. So let's use quadratic formula. So this is a quadratic formula here, and we see that B is 8, A is 1, and C is 14. So let's substitute the values. So when we simplify, we get this. Now we see that we can factor out 2. So these are the two values of x, and we'll substitute each two values and we will get the value of y. So negative y, this equation was given to us. This is the equation 2. Okay, so because it is simpler, we can use equation 1 also, but this is simpler to use. So we use this and then we put the value of x here and simplify and we get the value of y. Now this we used x is equal to negative 4 plus root 2. Now let's use negative root 2. So now when we use negative 4 negative root 2 and we use this equation and substitute it here. So we get the value of y here. So when this was the x, we got y as 9 minus 4 root 2. When x was negative 4 negative root 2, we got y as 9 plus 4 root 2. So these are the two solutions. We get it. We solve these equations, these two nonlinear equations, like one was linear and one was nonlinear, using elimination method. Let's try to do some word problem also. So the question here says that range in miles of a broadcast signal from a radio tower is bounded by a circle given by the equation. So this is, suppose, the broadcast tower. Okay. So the range in miles from a radio tower is bounded by the circle. So this is the circle which includes, which is the boundary. This is a signal boundary where it can, this is where the signals can be reached. And a straight highway can be modeled by the equation. So this is a straight highway and it can be modeled by the equation this. Okay. So for what lengths of this highways are car able to receive the broadcast signal? So when the car is here and up to the car is here, this length here these are the lengths where the cars on the highway are able to receive the broadcast signal. Not here and not here, because they are outside the circular signal boundary. So basically, we have to find the intersection of this equation and this equation, where we will get this point and this point. Basically, cars can receive the signal where straight highway intersects the circular boundary. So we have to find the intersection for both of these and find the point, and the cars moving in this green line can receive the signal from the radio tower. So this is a tower, okay, and this is the circular signal boundary, which is the blue color. Okay, this is the range of broadcast signal from radio tower, this blue, and this red line is full. It is a highway, okay, and this green is the signal coverage on the highway. So we have to find these intersection points. So we'll substitute the highway minus 2ab, and they'll be simplified and multiplied by 9 to the equation, so that we get rid of the 9 and we simplified it. Now, if we factorize this will give us x squared minus 36x plus 18x minus 648. Okay, so if we simplify this will give us x. So now when we factorize, we get like x minus 36 and x plus 18. So x plus 18 and x minus 36. And we know this is a zero product property. So x is equal to negative 18. Either of the factor can make this 0. So x is equal to negative 18 and x is equal to 36. Now we can substitute any of both of these in the highway equation. The highway equation was 1 minus 3x plus 30. Okay, so these are when we substitute x is minus 18 and x is equal to 36, these are the y values we got, 36 and 18. So these are the coordinates of 2 points, negative 18, 36 and 36, 18. Basically, these are the points. These are the points here. This will be negative 18 and 36, and this will be 36, and when we put this we get 80. So these are the 2 points. Now we can find the length of the highway that the cars are able to receive the broadcast signal with the formula of the distance, with the distance formula. So let's get it. So this is the distance formula from where we can get the length of this red. This is the where we can get the length of the highway that cars are able to receive the broadcast signal. So when we substitute the values in this, y2 minus y1 square plus x2 minus x1 square, we get 56.49. Okay, so that's the distance in miles, which these are the lengths of the highway that cars are able to receive the broadcast signal. Okay. So please continue doing the problems from the book, and please let me know if you have any difficulty, and keep practicing. Thanks. Thanks for joining.